we're back with a video now talking about the derivatives of inverse trig functions. We just looked at the overall general environment of inverse trig. That was a review from pre-calculus last year, just a quick one. But now we want to look at those derivatives. Okay, so you are responsible for the derivatives of inverse sine, inverse cosine, and inverse tangent. You don't have to worry about the derivatives for the other three, but you do want to focus on having these first three memorized. And as we're going to see, there's actually not a lot of a difference between them. But we're going to start with the derivative of inverse sine. Okay, so our goal is to get the derivative of the inverse sine function. And remember, that can also be written in this way as well, arc sine. Either one will work as far. You're going to see both of them potentially on the exam. The committee will go back and forth as to which one they use depending on the year. Okay, so our goal is to get the derivative of the inverse of sine of x. All right, so in other words, y is equal to inverse sine of x, and we want to get the derivative. And it's kind of weird to say, well, where do we start with all this? Because we don't have anything to go with as far as inverse sine is concerned. All right, if it was sine, then we could work with stuff, but it's not sine, it's inverse sine. But can we make it sine? And the answer is yes. Let me grab my other marker here. Okay, watch what we can do here. We can actually take the sine of both sides of the equation. We're allowed to do that because we can do whatever we want to an equation, basically, as long as we do it to both sides. All right, so we're going to take the sine of the left side, and we're going to take the sine of the right side. Okay, and when we do this, what ends up happening is we have the sine of y over here on the left, and then we have the sine of the inverse side. Well, the inverses, they wipe each other out. And all that's left is the original extension of x. So the sine of y is equal to x. All right, now why would we do this? Because now we have somewhere to go with this. We couldn't really derive the original equation, but this we can derive. We know implicit differentiation. Let's take care of our derivative in this regard. Okay, so the sine of y, through implicit differentiation, we know, and then we're doing the chain rule, we derive the outer function. Okay, so sine derives to cosine. We keep the inner function, so we keep y, and we multiply by the derivative of the inner function. And we know that since we're deriving with respect to x, the derivative of y with respect to x is that dy dx, which is again what we're looking for. Okay, so this is good that we have it here because we're going to want to solve for this in a moment. But not yet, because first we have to derive the other side. And the derivative of the other side, that's easy. That's just 1. So cosine of y dy dx is equal to 1. How do we get dy dx all by itself? Exactly, we're just going to divide by cosine y. All right, so we'll divide the left side and the right side both by cosine y. All right, and doing so, we now have dy dx is equal to 1 over cosine y, which seems like a good answer because it's not all that complicated. But the issue is we're looking for the derivative with respect to x, and we don't have x over here, we have y. So we want to get rid of that. Okay, we want to get this into it in terms of x, right? And in order to do that, well, we're going to have to make things a little bit more difficult before we make them a little easier. Okay, and here's what I'm talking about. We're going to go back to pre-calculus again, and we're going to focus on that big identity that we learned a long time ago, which is that the sine of anything squared, and I'll just use, actually I'm not going to use x this time, I'm going to use y. The sine of anything squared plus the cosine of anything squared, that's going to be equal to 1. Okay, we learned that in pre-calculus. That's one of our big identities. And again, you can put in any value that you want for y, and it's guaranteed to come out to 1. Check it out in your calculator right now if you want to pause this video. Okay, well, we have cosine of y up here. So let's solve this equation for cosine of y. That means we got to get rid of the sine squared y, which we can do through subtraction. All right, so cosine squared y is equal to 1 minus sine squared y. Okay, I'm just moving it from one side over to the other side. And now I got to get rid of a square. How do we do that? Exactly, square root. So we're going to take the square root of the left side, which we can do as long as we take the square root of the right side. We're going to do that as well. All right, so cosine y, right up here, that's actually equal to 1 minus sine squared y. I'm going to put that down now. All right, 1 over square root 1 minus sine squared y. Okay, It's like, well, wait a minute here. We've made it worse. Okay, we had just one term. Now we've got a square root, and we've got subtraction, and we've got a square. There's a lot going on here. Why are we making it all that much worse? The reason why is because back in our original, all right, taking a look at the brown only, not the pink. Let me get rid of the pink here. Okay, look what we know. All right, y was equal to the inverse sine of x, which meant that the sine of y was equal to x. Okay, the sine of y is equal to x. Well, here's the sine of y right here. That's really x. So we can substitute out the sine of y, and we can substitute in the sine, or rather just x. So instead of having sine of y squared, it's just x squared. And that's our derivative right there. 1 over square root 1 minus x squared. Okay. Now you don't have to know the whole process. I showed you the process because I wanted you to see it as opposed to me just putting that on the board saying that's a derivative, boom, go work with it. Okay. I wanted you to see why it comes down into that derivative. Okay. What we can determine is that if we do this whole process again, which I'm not going to, I don't want to waste your time, but if we do this all over again with inverse cosine, basically the exact same thing will come into play, except that, we need some space here, so somebody reads this. What we'll find out is that the numerator will be negative, all right? So the derivative of inverse cosine will be negative 1 over square root 1 minus x squared. It's almost identical to inverse sine. They're basically the same thing. One is negative, the other is positive. Tangent, or rather inverse tangent, think, oh, well, is that one worse? And no, in fact, inverse tangent, because of the way that the trig identities work, if you can see that video online, any site, look at Khan Academy or basically just Google derivative inverse tangent, and you'll see how it's all worked out. But because of the trig identity that we use for inverse tangent, involving tangent squared, it turns out to be 1 over 1 plus x squared. That's your derivative of inverse tangent.